Well, hello and welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is supplementary angles and vertical angles. Let's get prepared. We're going to need a pencil with an eraser, also some paper, and a calculator is optional for self-checking. Also, a straight edge is optional because we will be drawing some shapes and you may want to use that to draw some straight lines. Don't forget to pause the video from time to time to answer the practice questions and rewind the video if you need to review anything before trying to answer the questions. Okay, so before we do our vocabulary, I'm Miss G, and we always like to start our lessons off by doing some deep breathing exercises. So let's go ahead and breathe in and out 3 times. We're going to hold it in for a count of 3, okay? In the nose. Hold it for 1, 2, 3. Breathe out. Breathe in your nose. Hold it for 1, 2, 3. Breathe out your mouth. Okay, one more time. Breathe in your nose. Hold it for 1, 2, 3. Then breathe out your mouth. Okay, and if you need to do additional breaths, just pause the video and do some additional breaths. We want to make sure our minds are all cleared of distracting thoughts so we can focus on the math that we're trying to learn today. And geometry just happens to be my favorite. Math is everywhere naturally. So if you guys have had a chance to watch the, why do we learn math video, I do go into a little bit of why you can find math pretty much everywhere, including within your own body. So let's look at our first word, a theorem. A theorem is sort of like a law in mathematics. It's something that we know to be true because it is mathematically proven to be true. And like for instance, we will be learning about the triangle sum theorem, which states that every triangle has 180 degrees if you add up all of its angles together. So that's an example of a theorem. Okay. Oh, triangle sum theorem. I just talked about that. That just means that every triangle has 180 degrees angles when you add them all up. So if I've got 3 60-degree angles in that triangle, that should be correct because that would be an equilateral triangle, but that would be correct because all 3 of those 60s added together makes 180 degrees. Vertical angles are those angles that are across from each other on an intersection. They are not adjacent to one another. So in other words, they do not share a side, but they do share a vertex point, which is a vertex point is the corner of your angle, that little point there at each corner. Supplementary angles are 2 angles that add together to create a 100-degree straight angle. Complementary angles are 2 angles that when added together create a 90-degree right angle. A right triangle is a triangle that contains one 90-degree right angle inside. Adjacent angles are 2 angles that share a side and a common vertex point. It's kind of like adjacent angles are neighbors. They're right next to each other and they share one side of their angle. Actually, let me just draw a picture for you so you can kind of see what I'm talking about here. So like if I had this angle and I split it, this angle here would be adjacent to this angle here because they share this wall, this side. It's almost like they're neighbors and that's a fence separating them. That should be a straight line there. And then they share this vertex point here, this corner. So those 2 angles would be adjacent to each other. All right, and so the next one, is now these, I'm going to not go into these in too much detail on this video. I'm just going to briefly talk about these exterior and interior angles. Sometimes we refer to those as being, exterior is the angles that stick outside of a triangle, and then interior angles are the ones inside of the triangle. But exterior and interior angles are also created with parallel lines and transversals. And so when we watch the parallel lines and transversals video, we're going to get into all of these different angles here. Consecutive angles, same side and exterior angles, alternate exterior angles, all of these. So I put them on the vocabulary for today, even though we're not going to talk about these in today's lesson. It is part of the unit. So I want you guys to start seeing these words because they will be on this parallel lines and transversals video that we're going to do after we do this one and we do the complementary and adjacent angles video. So again, for today's purposes and for the triangle sum video that we're going to do, exterior and interior angles can be inside or outside of a triangle. I'll draw a picture so you can see what I'm talking about. So if I had a triangle like this, and all three of these angles would be inside, we're assuming they're all different sizes. So all three of those interior angles would be inside this big triangle here. Okay. Oops. It's hard to write with my mouse. But this little angle outside, like this angle right here, I'll change colors so you can kind of see what I'm talking about here. This angle, beep, beep, right there. That's going to be exterior because it's not inside of the triangle. Okay. Now, again, I'm referring to interior and exterior angles as being part of a triangle or outside the triangle. These are also going to have double meanings because there are interior angles in the parallel lines and transversals, and there are exterior angles in these as well. So so you'll get used to seeing interior. Basically, interior just means inside, exterior means outside. All right, so again, I'm not going to go into too much detail about alternate interior, same side interior, alternate exterior, same side exterior. All of that's going to be explained, and also these consecutive angles. All that's going to be explained on the parallel lines and transversals video, but I just wanted you guys to be, just get a snapshot of some of those words. All right, so lesson essential questions. We have, what are supplementary angles and vertical angles? Explain how to use supplementary angle relationships to solve for a missing angle. And explain how to use the vertical angle relationship to solve for a missing angle. Okay, so this is some of this you might have had if you had the, some geometry in the 7th grade. You might have talked about some supplementary and adjacent and complementary angles. So you may be somewhat familiar with these, but it's always good to review. Okay, so parallel lines and transversals. Again, we're going to have a separate video on this, but I just wanted you guys to kind of see what they're talking about when we mention parallel lines and transversals. Lines that never intersect each other, no matter how far they are extended, are called parallel lines. So you may have seen this in a previous grade level. These two lines right here, line AB and line CD, they're parallel to one another. This is the symbol for that. Line AB is parallel. Those two little lines there, that is the symbol for parallel lines. So that's saying that AB is parallel to line CD. Same with this one. You're saying line M is parallel to line N. So again, there are lines that go on forever in either direction, but they never cross. Okay, parallel lines never cross. And so these two lines as well are our parallel lines. Now, when you take a line and slice through those parallel lines, like this line here, EF, and this line here, T, and this line here, those are called transversals. Okay, so that's a line that intersects two or more lines, usually parallel lines. Okay, when a transversal cuts through parallel lines, many angle pair relationships are formed. So when we go into that parallel lines and transversal video, you're going to see some of those angle relationships that are created by two parallel lines being sliced or with a transversal going down the middle. Okay. All right, supplementary angles. Another name you might see for supplementary angles is linear pairs. And the reason why is because they create a line. So like, here's a good example. This line A, or this angle AB, this angle A, excuse me, and then this angle B on the other side. Those two angles create this line here on the bottom, okay? And all lines are 180 degrees, okay? So straight lines always have it's called a straight angle, and it's on straight angles are always 180. Now these are two adjacent supplementary angles because they're right next to each other. They share a vertex and a side. But here's some angles over here, this P and this Q. Those two are not adjacent, okay? However, they're still supplementary because if you put them together, they're still going to make this straight line, okay? So basically it's two angles. Here, I'll read it for you. Supplementary angle relationship or a linear pair is when the measure of two angles add up to 180 degrees. The angles may be adjacent, which is side by side, like in this case, or not adjacent. So here the Q and the P angle were not adjacent. We stuck them together just to show you what they would look like if you stuck them together. But definitely they're not adjacent here, okay? The straight angles form when a supplementary angles are placed adjacent to one another, creating a straight line or a 180 degree angle. Here's another example. These two, the 150 degree angle and the 30 degree angle here, those are adjacent and added together, they create this 180 straight angle line, okay? Over here, we've got two supplementary angles that are not adjacent, so but they still add up to the 180. These two angles are adjacent and also supplementary. Oops. And these two angles are not adjacent and also supplementary. Okay, so let's find some missing angle relationships using these supplementary angle pairs. Okay, so our first example is asking us to find the measure of angle X. Okay, so we have angle X over here and 103 here. So if I were to list this mathematically, I would say the measure of the first angle, and I'm just naming this first angle on the left, angle 1. Okay, so the measure of angle 1 plus the measure of angle 2, which is the X. Okay, I just labeled them 1 and 2. You could have labeled it A and B, you know, whatever you want to label it. I just labeled it 1 and 2. So both of those have to add up to equal 180. Okay, 103, I replaced my measure of angle 1 with 103 because we know that that one is 103 degrees. The X is what I replaced the measure of angle 2 with, and then I add those together and make them equal to 180. Okay, solve that equation by subtracting 103 on both sides, and we find out that the X over here, this angle, has to be 77. Okay. Now, if you want to check yourself to make sure you're right, just take that 77 and add it to the 103 to make sure that it does equal 180. Okay, so here's a little more complex problem. We've got a 2y angle and also a 74 over here, and they do create this straight line, so it does look like they're supplementary. So I'm going to label the first one measure of angle 1 and the second one the measure of angle 2. Okay, so the measure of angle 1 I said was 74. The measure of angle 2 is the 2y. Added together, they should equal 180. Subtract your 74 from both sides, and you end up with 2y equaling 106. So divide the 2 on both sides to solve that two-step equation, and your y ends up being 53. Okay, now that is not the angle measurement. Okay, that y is simply what this y stands for. Okay, so you're going to need to plug that in to find out what this angle truly is. Okay, so to do that, substitute to find the measure of angle 2y, or that second angle there. Okay, so we're going to plug in 2y by doing 2 times 53 because we know y is equal to 53. And whatever that is should be our angle. Okay, so 106 is equal to the angle 2y, which was our second angle here. Okay, and again, this is a little bit harder because you had to do that extra step to find out what 2y was. Okay, after solving, a lot of my students will stop here. They'll find out what y is, and then they'll stop and not realize that that's not the angle. It's 2 times y. So you had to multiply that 53 times 2. Okay. Now we've got 2 more angles over here. We've got an angle z plus 5 and an angle 84. And I know that those 2 angles have to equal 180 for them to be supplementary. Okay. So I'm going to plug it in. The z plus 5 is my first angle. The 84 is my second angle. So z plus 5 plus 84 should equal 180. Okay, I can combine my like terms. And when I combine my like terms, I end up with z plus 89 because I could combine the 5 and the 84 together to get this 89. Okay, now subtract your 89 from both sides to cancel that 89 out. And I end up with z equaling 91 degrees. Okay, now that again is not the measure of this angle. That is just the value of z. Okay, so we're going to need to add 5 to that. We're going to need to substitute z plus 5. We know z is 91. Add the 5 to it, and we're going to end up with a 96 for the measure of angle z plus 5. Okay, the fourth example, we have the measure of angle 1, which is a minus 13, plus the measure of angle 2, which is this 53. And this is an exterior angle that's connected to this triangle. However, both of those are creating this straight line here, so they are supplementary. Combine your like terms. This time a negative or a minus 13 plus this 53 is going to give me a positive 40. Okay. A plus 40 equals 180. Subtract your 40 from both sides, and A is going to be 140. Okay. Last step is to plug that in, substitute it in. A minus 13, 140 minus 13. It's going to give us 127 degrees. And so the measure of angle A, oh, that's not right. All right, so we fixed that. So the measure of angle A minus 13 has to be 127 because that is what we get when we subtract this 13 from our A, which is 140. Okay, so these are basically some common problems you'll see. You'll see supplementary angles showing like this, where you have the straight line just divided into two different angles. Here's the same thing, but it's just turned the other way. And then here's one with two parallel lines with the transversal going through it. And I know they're parallel because of those two little arrows right there and right there. That signifies that they're parallel. And then sometimes you'll see it, sticking out of the triangle, but it's still a straight line. So this angle and this angle has to add up to 180 to make this straight line. Okay, so set up an equation. This is basically the steps that we just did for all four of these. Set up an equation by adding the two supplementary angles together. That's what we did on the first part of each one of these. Make them equal to 180 and then solve for the variable. And then substitute the variable back into the unknown angle if necessary. So if you have something like this or like this where you got to substitute that back in and find out what it is, minus 13 or plus 5 or whatever, then do so. On this side, we didn't have to do that part. All right, vertical angles. Now, vertical angles are made by intersecting lines, okay? And they're always across from each other, okay? So look at this example here. We've got intersecting lines. This angle Y is vertical to that angle Y. Notice they do not share a side. These two sides are not being shared with these two sides, okay? But they do share this vertex point in the center, okay? Also, angle X and this angle X are both vertical angles. Now, vertical angles are always congruent to one another. So they're always equal. So this Y has to be the same measurement as this Y. This X has to be the same measurement of that X. So here we have another example where A and B are vertical angles, so they have to be equal to one another. This one, though, is a little tricky because this line here, it's kind of hard to see, but it bends. It's not a straight line. This line goes boop and then up a little bit. So because that line is not a straight line, this angle measurement's not going to be the same as this one. So this one, even though it looks like it might be vertical, because this line bended a little bit, it made it not vertical. Okay, so just keep that in mind. If you're given the measurement of one vertical angle, then you can make that equal to the other one in order to solve, to get it. Okay, so let's read this. A vertical angle relationship is when two opposite angles form a cross from each other from two intersecting lines. Vertical angles are not adjacent or not right beside each other. So they'll always have that, common point in between them, but they're not adjacent. X is adjacent to Y here. They share this wall, this side, but and this Y is adjacent to this X, and this X is adjacent to this Y, and so forth. But the Y and the Y are not adjacent, and this X is not adjacent to that, but they do share the vertex point. Vertical angles are congruent, which means their angle measurements are equal to one another. These two angles are not adjacent and also vertical. These two angles are not adjacent and also not vertical. Okay, so now we're going to find the missing angle relationships using vertical angles. And since they're congruent, we're going to set these equations up. We're not going to add them up and make them equal to 180 like we did last time, because that's a supplementary relationship. Vertical angles don't, they could be any measurement, really. So let's go ahead and look and see what we have for number 1 here. Okay, so the first thing you would do is you would take your two angles and you would make them equal to one another. Okay, well, when I did that, I solved my equation. Okay, because x has to be equal to 103 if they're vertical, and these two are vertical. Okay, now if I wanted to substitute to check my answer, I would just substitute the value of both to make sure they're equal, and they are. So basically x, the unknown angle, is equal to 103. So that one's pretty simple. Okay, now let's look at the measure of angle y. We need to find the measure of angle y here. So we're going to set it up. Measure of angle 2 is equal to measure of angle 1. These two have to be equal for them to be vertical. Okay, so 2y is equal to 94. I'm going to solve that equation by dividing by 2 on both sides, and y is going to be 47. Okay, that is the measure of angle. Ooh, that should be the measure of angle 2y. My bad. All right, sorry about that. I had the typo up here. So that should be find the measure of angle 2y, because that's a 2 in front of that y. All right, so we made them equal to one another. We divided by 2. We found out what y was equal to. Now we need to plug that in to 2y, or 2 times y, to get our full angle measurement. So 2 times 47 is 94. So since this is 94 over here, we know this has to be 94 as well. So we know we got the right answer because they have to be equal to one another. Okay, let's look at the measure of angle 1. Okay, so now we have z plus, now I'm just asking you to find the measure of angle 1. So we need to label angle 1 as z plus 5. So z plus 5 is equal to 84. Again, vertical angles have to be equal to one another. Okay, so this has to be equal to that. And so we subtract our 5 from both sides, and z ends up being 79. We substitute that back in. Z plus 5 is what we're trying to find out, which is 79 plus 5. And so our measure of angle z plus 5, or the measure of angle 1, is 84. I may go ahead and check that. Okay, so now let's look at, I went ahead and changed it up there so you guys can see that angle 1 is the same as angle z plus 5. Okay, so the last example, we have this triangle. This angle here is vertical to the a minus 13 angle, and we're trying to find what a minus 13 is. So measure of angle 1 has to be equal to the measure of angle 2. So these two have to be equal. We're going to put the 53 on this side, the a minus 13 on the other. We're going to add 13 to both sides to cancel that 13 out. And a ends up being 66. So I need to plug in that 66 in for that a to find out what that full angle measurement is. And 66 minus 13, after I substitute it in, ends up being 53 degrees. So the measure of angle a minus 13, this angle, is 53. All right, so set up an equation by making each vertical angle equal to one another. So this is different than the supplementary. Supplementary, we added them and made them equal to 180. This one, we're just making the angles equal to one another. And then solve for the variable. Substitute the variable back into the unknown angle if necessary. All right, let's try this. Okay, so go ahead and pause. I'm going to count to 3 and try to find that unknown angle. So you're trying to find the measure of angle x here using supplementary angle relationships. And this one is also a supplementary pair. And you're trying to find that full measure of y plus 17, that angle there, that whole angle there. Okay, pause. 1, 2, 3. Okay, so this one, the measure of angle 1 plus 2 is 180. So that's the general format of your supplementary angle pair relationship. So we're going to substitute measure of angle 1 with 141, the second angle with an x. Subtract your 141, x is 139 degrees. That is not right. That should be 39. Whoops. Okay, we changed that. All right, so the answer should be x equals 39, because 39 plus this 141 does equal 180. Right? For the second problem, we have the measure of angle 1 plus the measure of angle 2 equals 180. The first angle was 60. The second angle, I made y plus 17. And then we combined our like terms. 17 and 60 makes us 77. Subtract your 77 from both sides, and y ends up being 103. So now we need to add that y to the 17 up here. Okay, so 103 plus 17 is 147. I'm still coming out with a wrong answer there. Hang on. All right, I'm finding all kinds of typos today. Okay, so really the answer should be for this angle here, y plus 17, 120 degrees. So if you got it that's awesome. Okay, let's try the second problem. Let's go ahead and do supplementary angle relationships to find the measure of angle x plus 24 over here. And over here, we're going to solve for just the y this time. Solve for just the y. Pause. All right, so here we have the measure of angle 1 plus the measure of angle 2 equals 180, supplementary pair. We are subtracting the 141 from both sides after replacing the 24. Hang on, this is not right. Okay, let me fix that. Okay, so we've got 142 is our final answer for this one. And I realize that this problem here is similar to the one we did on the previous slide, but I wanted you guys to see that sometimes they will ask to solve for just the variable, and then sometimes they'll ask for the entire angle, right? So on the last problem you did on the previous slide, they wanted the entire angle. So to find that entire angle, y plus 17, we had to solve for y first and then plug it in and add the 17 to it. Well, on this problem, all we had to do was find out what y was. So we could stop there after we find out that y is equal to 103. Okay, so I wanted y'all to see how that works. So, pay attention to the directions, because sometimes, it'll throw you off if you don't know what they're asking for. So just pay attention to, the angle measurement that you're trying to find. In this case, they're not even asking for an angle measurement. They're just asking for how many degrees y is, really. Okay. Let's try a third one. Use the vertical angle relationships this time, vertical angles, to find the measure of angle A here and the measure of angle B plus 17 over on the right. Pause. 1, 2, 3. Okay, the first one, both angles are vertical, so just make them equal to one another and you're already done. On the second one, we have a little more work to do because we had to make these two equal to one another first and then subtract our 17 from both sides to get the 43. That's what B is equal to. Then we had to substitute it back in to add it to the 17 in order to find out what the full measure of the angle B plus 17 is, and that's going to be 60 degrees. All right, the last one, use the vertical angle relationships to determine the measure of x plus 24 over here and y plus 17 on this side. Okay. The measure of angle 1 and equals the measure of angle 2, so those two have to be equal to one another. Subtract your 24 on both sides, and x is going to be 14 degrees. So then you're going to add that 14 back into this angle, and 14 plus 24 is going to give us 38 degrees. So the measure of angle x plus 24, this angle here, is 38 degrees. On the second one, make the angles equal to one another. This time we're going to subtract 17 on both sides. Y is 43. Add that 43 back in to get that angle 60. Now, if you know that these are vertical relationships, then you know that this angle has to be 38, just like this angle. And this angle has to be 60, just like this angle, because you know vertical angles are equal. However, when you're doing math problems and they're asking you to show your work, you do need to show that you know how to set that up, okay? Because not all of them are this easy. So just make sure you know vertical angles are congruent. They're equal to one another. All right, so what are supplementary angles and vertical angles? So go ahead and try to answer this one on your own. Pause. Okay, the answer is a supplementary angle relationship. Another name for that is a linear pair, is when a measure of two angles add up to 180. Okay, a vertical angle relationship is when two opposite angles form across from each other from two intersecting lines, Vertical angles are congruent or equal to one another. The second essential question, explain how to use supplementary angle relationships to solve for a missing angle. Pause. Set up an equation by adding the two supplementary angles together and making them equal to 180. Then solve for the variable. Substitute the variable back into the unknown angle if necessary. Explain how to use the vertical angle relationship to solve for a missing angle. Okay, set up an equation by making each vertical angle equal to one another, and then solve for the variable. Substitute the variable back into the unknown angle if necessary. Well, wow, that was a little bit of work there doing those angle measurements, and this cute little pig's going to help us with our vocabulary. Okay, so a theorem is a true statement in mathematics that is proven mathematically. Triangle sum theorem is the theorem that states that all angles within every triangle add up to 180 degrees. Vertical angles are angles that are across from each other on an intersection, and they share a vertex point, and they're also congruent. Supplementary angles are two angles that form a straight line. They add up to 180 degrees. Complementary angles are those angles that add up to 90 degrees, or a right angle. And then a right triangle is a triangle that has one right angle in it, which is a 90-degree angle. Adjacent angles are those that share a side and also a vertex point. And then all of these, exterior, interior, and all of these, we're going to go over in our parallel lines and transversals video. So we'll go over those in more detail. Okay, so great work, everybody. A bouquet of math blossoms have opened up in your mind today. To further improve your math language skills, remember to practice by doing your classwork and homework, study at least 10 minutes a day, ask for help if you need it, and learn from your mistakes. Always do your best to try. I'm Miss G. Thank you for watching this Math Blossoms video. The next video in this series on triangles and angle relationships is the video on adjacent angles and complementary angles. I think it's listed as complementary and adjacent. So go ahead and check that video out. And thank you for watching again. And now it's time for me to say, it was lovely teaching you math today. Bye.